So here we are, Statistics and Mechanics, Year 1, Mixed Exercise, Chapter 7, Question 10, last one in this exercise. Okay, so pharmaceutical company claims that 85% of its patients suffer from a chronic rash recover when treated with a new ointment. A random sample of 20 with the rashes taken for the hospital records. Brilliant. Write down a suitable distribution model to model the number of patients in the sample who recover. Okay, 85% recover, so we can say X is a number of people who recover, and it's going to be binomially distributed with a sample size of 20 and a probability that they recover of 0.85. That's it. 1 mark, done. Right, given that that claim is correct, find the probability that the ointment will be successful for exactly 16 patients. So with that, we are going to use this binomial and we are going to look up the probability that X is exactly 16. Okay, so onto the calculator now for that one. And where's the calculator? Using this calculator here, we'll go down to distributions. Okay, it's a binomial distribution. Okay, number of trials 20, probability of 0.85. Okay, and go. Right then, we don't want less than or equal to, we want to change this to equals. Okay, X equals, there we are, 16, go, there it is, that one there, 0.182. Okay, there it is, 0.182. All right, that's it. Right, the hospital believes that the claim is incorrect. Okay, and the percentage who will recover is lower. That's important, that they think it's lower. You're either going to get lower, higher, or not. That probability. We've got lower this time. From the records, an administrator took a sample of 30 patients, okay, who had been prescribed the ointment. She found that 20 had recovered. Okay, so we need to change distribution because the sample size is now 30. We still have a probability of recovering of 0.85, and so now we can set up null and alternative hypothesis. Null hypothesis is always the same, that the probability equals 0.85. It is correct. This one, the alternative is that it is lower, so the probability is less than 0.85. And they want us to test this at a significance level of 5%, which of course is 0.05. Okay, it's lower than, which means it's a one-tailed test. Lower and greater than a one-tailed test, not equal to, is the two-tailed test. So what do we have here? We want to know what the probability of X is, that 20, so that X is less than or equal to 20 patients have recovered. Okay, so what does that come out as? Where's the calculator? Here it is. Change it over to the 20 and less than or equal to, here we go, 20. Okay, 1. That seems like an odd answer, but then this distribution isn't correct. This is the old distribution. Okay, this was a sample of 20. We've just been told the sample is 30. Okay, still on 85, there it is, and changing that to, we got less than 20. That's better. Okay, so you can see there. Now if you just think there for 0.009, okay, There. 0.0096, I think it was. Okay, and is that less than the significance level? Yes, it is. Okay, which means, okay, that there, it was a positive result. There is enough evidence to reject HO. We're always looking to reject it or not reject it, and that's the tick of the cross. There is enough evidence to reject HO and accept the alternative. So the percentage of patients getting better is less than 85%. Okay, that's it done. Just remember, if we have a look at this, how many patients would they have needed to say, no, it is 85%? Because 20 does seem a bit low. I mean, 20 out of 30 is only 60% of them, isn't it? Okay, 66%. So how many would we have needed? At what point? Where would the critical value be on this one? 22? 22 would have been acceptable. 21? 21 would not. So they needed to see 22 people, because then it is above 5%. You see 6.9% in that case. And then they would have been like, yeah, 85% of the people get better. But because those 2 people were not, it is not. It is rejected. Okay. That is it. We will carry on now with chapter 8 and the forces work.